So welcome to part 3 of our SL index calculation. So in second part we learned how to calculate the length of our final reach, and we then added a new ID field. If I open its attribute table, so my attribute table looks something like this. I have deleted all the unwanted fields here, okay, using this delete field button, okay. And then I have added new IDs and length of the reach in the same way that I demonstrated in part 2. So for demonstration purpose, I have filtered only 60 segments and deleted the others. So, okay, so you can do the same. I mean, you can have 100 segments or more than 100, whatever feels comfortable for you. And then, so in this video, we are going to learn how to calculate our delta H. Okay, so the difference between the elevation of the reach, or the change in elevation between the 2 points of the reach. Okay, so for this we need a digital elevation model. Okay, so I'll go to this browser panel here, and for DEM, I have this DEM area of interest diff. I'll provide you the link for downloading this DEM in the description box. Okay, so you can download this, load this DEM by just dragging and dropping it. Okay, so let me put that the bottom so that we can see other layers. Okay, so this is the stream, this is the reach which I have just filtered out. Okay, okay, so we have to calculate here the difference of the elevation between this point and this point, this point and this point. Okay, so for that, of course, we need some points. Okay, we need vector points which we can create on these on these ends, on this first vertex, on the last vertex of each segment. Okay, and then we will sample the raster for elevation values. Okay, so before we do that, we have to process our DEM to fill the sinks. Okay, let's first check whether our DEM is in yeah, it's in geographic coordinate system. First we have to reproject our raster to projected coordinate system. Okay, so for that, go to raster. Okay, and then projections and warp or reproject. DEM, your target CRS will be 43 knots because this area falls in 43 knots zone. Okay, so you have to input the node data value, go to its properties here and scroll down, and this is your node data value that you have to input. Okay, so here just paste this value. Okay, and we are not going to do any additional setting. If this was integer 16, if I'll check it again. So yes, it's integer 16. Okay, so output data type is integer 16, and then you can save your DEM to the folder. Okay, just change the name. Click on save and then click on run. Okay, close it. So this is my reprojected DEM. Okay, and then I'll perform one more processing which is called fill sinks, so that if our DEM have any sinks, that can be filled. Okay, or that can, those values can be interpolated. Okay, so here reprojected DEM. Okay, and the slope for here in this region I'll use as 0.01. Okay, we are not going to get into the details of this minimum slope and etc. And then click on run. Yeah, so the RDEM is filled. Okay, and I'll keep it here. I'll switch others off and collapse all the layers. Okay, so now we want to sample the raster values using some vertexes. Okay, at these points, right? So how we can do that? We will go to processing toolbox and we will create vertexes. Okay, so if you type extract specific vertices, here you will get it. Okay, and we are going to use, of course, our final reach layer, and vertex indices will be our first vertex is indicated by 0, okay, and comma, and the last vertex of a particular feature will be represented by num minus 1. Okay, so this is what we need. You can save this file as vertices. Okay, click on save and then run. It's finished. So we have these vertices, but the problem here is that they are duplicated. Why? Because for this segment, this is the first vertex, this is the last vertex, and for this segment, this is the first vertex and this is the last segment. So in this way, there are so many duplicated values. Okay, so we have to remove these duplicate geometries. So for that, we need another processing which is called duplicate, remove duplicate, delete duplicate geometries. Okay, so we'll use vertices and our layer will be cleaned. Okay, so we'll save it to file and we will call it cleaned vertices. Okay, click on save and run. Okay, now our vertices are clean and we just have one vertex at these points. Okay, so now we have to sample our raster for elevation values. Okay, so we will use sample raster values. Okay, so our input layer will be clean vertices, raster will be filled DEM. Here you can provide output column prefix, let's say elevation. Okay, so we are sampling elevation values because this digital elevation model is representing elevation in a particular place. Okay, so elevation samples. Click on save, then click on run, close. Okay, so if you will look into its attribute table, here you will see that we have got our elevation values. Okay, at some point it is null, maybe because you see there are a few points which are outside. Okay, and maybe at some points the values are not correct. Okay, so we have got the new ID. Okay, so let's arrange it in this way. So yeah, new IDs. Okay, at so you see now we have elevation value in a sequence. Okay, right. So to calculate these values, to calculate the elevation difference, what exactly we have to do here is to subtract this from this, right? So this from this means that your new ID is 1 minus 2, and here it will be 2 minus 2, and here it will be 4, this minus this minus this. Okay, in the same way, so they are in sequence, right? So we are going to do perform these calculations in the end using Excel sheet. So for now we will just keep this as our result. So now there is only one parameter left, which is your L. Okay, which is your length of the point of divide from the midpoint. This is what we have to calculate now. So we will do that in our part 4 video. Okay, part 4 of this SL index calculation, so that you can go to the to the things one by one. Okay, so let's meet in part 4 now.